So in the last video, we talked about how two vectors are equal if they have the same magnitude and the same direction. It doesn't matter exactly where you put them on a coordinate axes. But to help us compare them, it's useful to put them in what we call standard position. So standard position just means we put the initial point at the origin. Then whatever direction it's going in and however long will determine the rest of the vector. So we have a special term called a unit vector. And a unit vector is just a vector where the magnitude is 1. It has a length of 1. Just like the unit circle had a radius of 1. So we have some special vectors that we'll just use to describe the rest. I is the unit vector whose direction is along the positive x-axis. So that would be this vector right here. And J is the unit vector whose direction is along the positive y-axis. So that would be this. And by putting those two vectors together in different ways, we'll be able to write any vector. So this says, if V is the vector that goes from 0, 0 to AB, we can write it as AI plus BJ. So what that's saying is if we have any point here, it could even be down here. So this is A, comma B. You know, let's say it's, well, negative 0.9, negative 0.8. Okay, since this is less than negative 1, negative 1. This vector right here, we would write as negative 0.9i minus 0.8j. And when you've got it in that form, we can find the magnitude. Now, notice the magnitude, the length, is just going to be what we've called r in polar form. So you'll notice this formula looks exactly like what we've had for r in polar form. So the magnitude is the square root of a squared plus b squared once you have it in that form. So this says, sketch the following vectors and find their magnitude. So 4i plus j, we're going to go over 4 and up 1, and that would be this vector. So the magnitude would be the square root of 4 squared plus 1 squared. So we'd have the square root of 16 plus 1, which is the square root of 17. So our magnitude is the square root of 17. Okay, let's do one more. Okay, so this is 5 minus 3j, so that would be this vector right here. So the magnitude of this vector, we'd have the square root of 5 squared plus negative 3 squared. So the square root of 25 plus 9, so we'd have the square root of 34. So the magnitude formula here is really the same as the absolute value of a complex number, or that r value in polar form.